A couple of the tool holders which I'm making need big holes in them. Now they're not super critical, so I could just spiral mill them. And from the size, I could also just bore them with my existing import boring tool. But wait, what's this? This Narex VHU80 needs a 40 taper shank. I've got a slug of steel to make the shank, and I've also got a bar to make the differential stud to pull them together. So I think I'll make the stud first.
Mail time.
Man, what have we got here?
Well, I thought you could do with a decent boring head.
Ah, man, this is fantastic. So this is one of those Volhopter style boring and facing heads. It's called the VHU80. It originally had a
4 more staples.
Shank on it, so I'm going to have to make up the 40 taper shank, but luckily they were designed to have replaceable shanks, so that's going to be easy enough. Oh, nice. So when I was down in Malta, I saw that Luke was using these ball bearing drilled out with a magnet put in it.
It helps keep things square in the vise, really.
So for something like a cast part or something that's a bit rough, just magnet this onto the vise and it gives you a single point of contact to press against the part. Thanks a lot. I really do appreciate that Luke sold me this facing and boring head, because he's already got a Volhopter and a D&Andrea, which are the most sought after versions of this. Now, seeing as it was made in Czechoslovakia, that kind of reminds me of my favourite Sopranos scene. I'll leave a link. And Czechoslovakia hasn't been a thing since 1993. It's got to be at least 31 years old. There's no obvious damage to it. There's only very, very mild signs of a bit of staining or light corrosion on it. You can see no obvious scratches or gouges in the corner where it might have hit anything. And apart from somebody writing some notes in it with a Vibra pen, German for open and close, it really is in great shape. The manufacturer, Narex, is still around. They've got a very good website with very clear access to the manuals and spare parts catalogue and all that sort of stuff, which is great. I'm obviously going to have to build a 40 taper shank for it. The way Narex mounts it is with this bolt pattern. They mount a flange, and then on top of that flange they mount the 40 taper, but with a much extended skirt of 110mm diameter with 4 bolts through into that intermediate flange. And at first that was what I was going to do as well. But then Luke pointed out there's a thread in here. And he'd obviously been watching videos. Volhopter mounted their tapered shanks by using an internal thread. And since you can never have too much clearance vertically on a mill, it's really quite attractive to make up a 40 taper shank that mounts like Volhopter does. To do that, because you can't screw it all the way down with the keys, I'll have to use a differential screw. Volhopter used 16mm thread on one end and maybe a 20mm on the other, something like that, with 1.5mm pitch and 2.5mm, giving the 1mm differential pitch. So I'll use the same. You can see there's a centering boss here that I want to use. And just make up the 40 taper spindle, taking the normal pull studs on the one end with a M28 by 2.5 non-standard thread on this end to match up with that differential stud. I'll cut the threads with this brazed carbide lathe tool, but it's got a nasty chip out of it from its last use, so let's go and sharpen it. About 7 degrees should be enough. Now, grinding carbide is supposed to be really bad for you, the dust, so shop vac. I had been taping this hose to sort of a funnely thing, but I've decided to 3D print something, be a little more permanent, a little easier to use. So this should tide me over until I've got my new dust collecting wheel guard finished. And even with the shop vac, I also wear a dust mask. Nope, that tip's still not quite there. Got one of these sort of diamond hones, so I'll just give it a little bit of a dressing up with that. And just also round the tip just a little bit. So what's that now look like? So these are like the original ground sides as they came from the manufacturer. How does that radius on the nose look? Looks like I've broken it a little bit. And then the side I reground. Got a wee bit of a facet going on there. I think that'll be fine. Mail time. Alright, rags. Excellent. I didn't have enough rags. Oh, wait. There's more than rags. Excellent. So after Christian gave me some CBN inserts and I used them to turn down some high-speed steel, he said he found another one with a smaller nose radius and sent me that to try out as well. And also, it looks like some of those, what are those, W shapes? Don't have any holders for them, but what do we got here? All right. Brilliant. And the matching boring bar. Thank you very much. A similar, slightly heavier boring bar. A 2-insert end mill. But the star of the show, he somehow managed to end up with 2 of these centrifugators, or whatever they're called. Center finders. And offered to send me one. And I've never tried one of these out, so I really appreciate it. So these ones you can just hold the tool steady and run the tip right around to sweep a bore and therefore touch off. Thank you very much, Christian. That's brilliant. Got positive feedback on using swing music in my last week's video. That was inspired by seeing Marina and the Cats opening for Calexico. I really like the setup with splitting the drum kit between the lead singer and the drummer so that the two of them are sort of both on the kit at the same time. It's a very cool groove they've got. Right, let's go to the lathe. So this is a 30mm bar. It would fit through the spindle of my lathe, but the lathe's currently got the collet closer in it. So let's pull the collet closer. Luckily that's also really easy on this lathe. Simple as that. Okay, so this here is 30mm bar. If I just chuck it up, it turns pretty straight. This is a very nice 3-jaw chuck. But when I inserted it right through the spindle bore, I got a lot of run out. And I could see here that with it lightly chucked up, this jaw is not gripping. Inside the spindle, there's a key, which this slots into, to prevent rotation of the collets while they're being tightened up. And that key is what stops the 30mm stock going right through. Right, it's not a real deal breaker because I've got about 120mm to that key. And I'd already started designing another tool, which I needed 120mm offcut. So I'll just chop this once at 180. The stud I'm making is going to be 60 long. And then once that's parted off, the rest can be used for my next tool. You know, I've said it before, but I'm going to say it again. These Baco plastic frame hacksaws are awesome and also pretty cheap. I got this one off Amazon. I'll leave a link below. You might be wondering what sort of steel I bought. It's EC8. That's also known as 16 manganese chrome 5, 1.7131. And in the ANSI world, they call it 5115. So this is a steel that's designed for case hardening. I don't know if I will case harden them, but if I do, at least I got the right steel for it. Now the first thing I'm going to do here is put the hex into the end of it. So first I'll center drill. I probably should have ground a flat on this for wrenching, but I don't think the rotational loads are that high. Man, that fit is awesome. This is the surface I hard turned in a previous video. It's a high-speed steel. Okay, so now we're coming to the bit that's caused me a lot of issues in the past, rotary broaching. This is a pretty large broach as a 10.2mm broach for a 10mm Allen key. Luckily, being a 6-point, the individual points are not quite as much material to remove. I've had problems in the past when doing square broachage holes where the corners are just so far out, you have to remove so much metal that I get into trouble. But let's see if this works. How does it look after the first couple of millimeters? Well, so far so good. I've still got the corners on my broach. Yep, still cutting nicely. That's about 4mm in. I want to go in about 10. And it looks like my broach still has its nice sharp cutting corners. Okay, well that looks like it went easy enough. It is reasonably loose, but we've gone in a decent depth. Seems to be cut nicely. So let's call that a day. Start doing the threads. There's very, very slight dulling of the corners, but I got a feeling that I might not have quite caught them when I dished the end, so that might not be anything new. And thanks to my mate Luke for the ultimate rotary broach tool. Well, it's been a very nice warm summer here, so all the veggies are doing really well. It's time to start getting some jalapenos smoked. These plants were carryovers from last year. The jalapenos survived, the habaneros died. So these are new plants. Plant's still flowering nicely, so we should get plenty more chilies while the weather stays warm. So, where was I? Ah yeah, turning the differential screw. So I've already made up a gauge just to test this thread once I've done it. This end's actually going to get a smaller thread, the 24mm 2.5 pitch, but I'll just do this thread on it first just to dial in this tool, since I've set it for the first time. The reason I switched to this tool instead of inserts is because I then want to do the second thread in the same setup, and this way I can sort of reach in behind the alignment boss here and cut both threads. I put the wrong Z dimension in, so I stopped a millimeter too short. I have to recut that, and it's a bit too tight, so let me just reduce that diameter a little. Okay, it's not the greatest tool, it's a bit rough there. I'll just give it a good wire brushing. Yeah, I definitely get nicer, smoother threads with the threading insert rather than with the Braze Tool carbide cutter, but hey, it'll work. Right. Just offer up the real one. Oh, that's looking great. Okay, with that dialed in, I can now just turn this thread back off. Okay, that was done. I thought I was adding an end radius, which would be up here, but I wasn't. I put a taper on, so let's clear that. Don't want a taper, let's put a radius on there, which I don't really need for this first part, but I want to see what it looks like. I'll need the radius then when I do the thread undercut. I really love CNC for those like blended radius moves. This coarse thread really takes quite a large number of passes to cut, but that's what CNC's for. So it's looking pretty rough as I expected, so I'll just run the toolpath again to try and clean it up a little. Next I need to make a relief groove here. I've just realised that although I've got a bunch of different right hand turning tools, I don't actually have a left hand turning tool, which is what I would need to cut that relief groove with the radius in the right place. So I think I'll just do it with a parting tool, and there won't be a radius on it, but oh well. There's really quite a pucker factor when you're working this close to the chuck. Just double check, I want to head to minus 63. I'm currently at minus 38, 39. Okay, that's correct. And the second thread, 28mm major diameter with a 1.5 pitch. This tool macro first cuts the outer diameter to the major diameter of the thread, so basically cutting the tips off the thread. So it'll go in just a little bit. Those threads do look and feel pretty horrible, but hey, they did before as well. I just hope this works. Right, does it work? Alright. I wonder if this is how Mr. Whitworth felt the first time he took a bolt out of assembly A and put it into assembly B and it fit. Woohoo! So it's bottoming here. I'm going to need to turn it out 2.5. That's 1.5 turns. And you can see that the alignment boss is no longer down in its bore, so I need to shorten the whole thing. My understanding is you only need 6 full threads of engagement, so 1, 2, 3, 4, 5, 6, and I've got about 1, 2, 3, 4 extra. So there's about 10 threads in there. I'll just shorten this down a bit. This material was already at 30mm and was reasonably close tolerance. The surface finish isn't great, but I just polished it up so I can keep using that boss. That's it screwed right down. That's 1, that's 2.5. So now that centering feature will bridge between the two parts. Right, with the differential screw now finished, it's time to go on to the arbor. I'll have to just work on keeping that chipping because the swath that's coming off is so strong you can't safely remove it. I guess theoretically I could do this with 2 setups, but I feel more confident doing it this way. I'll do it with 3. So the next thing I need is a 14mm hole through the middle, which is the clearance drill for M16. Right, so lathes, being a Z X-axis machine, have a native orientation of G18, which you can see down here. But to use picking drill cycles, which are sort of standard to Linux CNC and I guess all controllers, you need to put the machine into the G17 mode, which makes it effectively like a mill. Obviously there's no workable Y-axis, but once you've got it in G17 mode, you can pick drill with the Z-axis, which is what I'm going to need for this deep hole. That's definitely not good. It's moved apart in the chuck. Luckily the first bit of that hole is a counter bore to center the pull stud. Thinking about it, since that's now
wonky. I don't want to do the counter bore based on that wonky bore, but since I'm doing this in 3 setups anyway, I guess I can already flip this. I was going to drill through and thread from this end, but I guess it doesn't actually matter. And if I flip it, I've then got a nice flat surface. The reason that would have moved is because the end wasn't sawn square, and once the pressure came on it, it probably lined itself a bit better. But let me have a think about this. Ah, shit. I was in G95 mode, which is distance per revolution, so I tried to make it move 70 millimeters per revolution. Ah, that was such a nice brand new drill donated by one of my kind supporters. Well, I'll have to chop the end off that and resharpen it. Right, next I need to get rid of that mess, sharp bits and stuff. I think the easiest way to do it might be to use one of these 25 millimeter end mills, because they can mount straight in here. And that way I can just take it down, make a new flat bottom, because the way that one tooth crosses to the center, this must be a center cutting end mill. It must be pretty complex to program the sharpening of these things. I'll put that down as not a great idea. I hope that this will be a better idea. This is a cemented carbide kind of stubby drill. Let's see if that can clean it up and make a straightish hole. So how far did this get knocked out of alignment? And how much can I improve by just turning it to a fresh spot on the 3-jaw? Nasty. At the latest, when I come back from milling, I was going to have to do this anyway, so it doesn't really matter. So there we have it, the beauty of CNC. Poking a 14mm hole down a piece of stock, a task that would have taken me all of a couple of minutes, maybe 10 on the manual lathe. But with a CNC, you got no feel. You make one tiny screw up of feed rate mode and everything turns to custard. Yeah, great for production, but for one-off stuff, you've really got to be on your ball. It's so easy to make a mistake. First I'll do the little 6mm deep 30mm alignment boss. I'll just take a cut to 22mm diameter first, just to mic it and make sure that this tool is actually set correctly. I was getting crappy surface finish, so I took a closer look and saw that my insert was chipped. And for this last couple of passes, to get a nice smooth bore, I've put in a high positive rake angle aluminium cutting insert. Those give a pretty nice finish for this sort of thing. Well, that looks about right. Very slightly oversized, 6 microns. I've done that measurement a couple of times. It seems reasonably repeatable, so that's exactly what I want. I finally got around to getting a stylus so that I can get up and actually touch the cycle button. Because I didn't put a bevel on this bezel, I can't get up and touch that with my fat finger. Need to bore out the clearance for the M24 by 2.5 hole. So therefore we've got tool 6 set, we've got speed 70, that's been working for us. I'll just go up to 20mm to start with. And we need to go back to -35. Right, no point doing this with an aluminium finishing insert, so I'll switch back out to a normal insert for steel. And next the chamfer on the lead-in. Well, that finishes off the lathe portion on this end. So now let's transfer to the mill. Dialing it around part is the perfect thing for trying out my new center finder. I need the probe pointing out the other side. Yeah, that should work. I think I'm a little fast there, aren't I? And too low. Should be there. Oh. Maybe I didn't have it tight. Now that's kind of cool. So I just zeroed my X and Y. And the tool length I can dial in against a known diameter bar, in this case 10.5 millimeters. Hold on, it looks like one of my main spindle contactors is not closing. And I can hear the 24 volt relays closing, but the spindle contactor is obviously not closing. So I don't think this area's got any problems. These are the main spindle drive, left and right. So the left and right is not the issue, it's the on off of the spindle. So it must be one of these contactors up in this row, I'm guessing, is just not closing. I guess I'm gonna have to pull the machine out, just have a look at which contact is sticky. That's a real bummer because it's already Saturday lunchtime. At the latest, I'm gonna need to start editing this video in a few hours time. This is the sort of issue I really don't need because I still have to do the slot this way, the drive lug slots this way, and then put it back in the lathe, do the taper, do the M16 pull stud thread and its counterbore. So wish me luck. I've really been doing my best lately to try and do finished videos rather than, you know, episodal things for reasonably simple projects, but sometimes it's really challenging within the scope of a single week. Well, I just rebooted the machine and working again. Just did a test cutting air with this, so let's give it a go. So the key that needs to fit into that slot is 8 millimeters, slightly below. Now the key is only 2.5 high, but I'm cutting this to 3. Because cutting slots is so common, I've got a little macro I've written, which is really easy to adjust the depth, width, and length of the slot. So at the moment I'm cutting undersize. Yeah, that's at the moment 7.41, and I want to aim for 8 with maybe just a smidgen over. Just sneaking up onto it there, so that would be 7.91. So here's the 8mm gauge block. Yeah, it's a Nice firm fit, that's for sure. Let's check it with the real thing. Oh yeah, that fits. That's a lovely fit. That's it for this setup. Next up are the slots in the sides. Right, found a gauge block stack to split the difference there to get that nice and level. Let's find the center of this part again. And these things really are easy to use. So we're at Y0. So now 0 the X. I guess that second touch off is not strictly necessary, but we're measuring slightly under the 63, like a tenth under. So it'd be a G0. Go to X 31.45. I think the batteries are getting flat. I thought I put new ones in. So that's a 10.5mm carbide blank. And our offsets are done. I use a mix of SK40 and BT40 tooling. The differences are the location of the gripper groove. The actual tapers are the same, except one of them's longer. The SK40's got a 2mm longer taper than the BT. So therefore you end up with different pull stud lengths. And I just measured those slots I need to make. Nominal 16, they're 16.2 on the SK and 16.6 on the BT. I'm guessing they loosened up the tolerance there to reduce the number of misloads for automatic tool changes. It's not really relevant for me. I'll just do the 16.2. Oh, I didn't think about that island in the middle, did I? I just remembered that I only roughed this in just enough so I could hold it. The taper actually comes down another 7mm, down to here somewhere, so I need to cut away more of this. The BT standard ones also go cut down quite low. Ah, that looks stupid. I'll just cut them right through like the SK ones are. Well, that's the milling finished. Now we're flipping it for the last few features on this side. Let's keep our fingers crossed. I need a 17mm alignment boss for the pull stud, and that's pretty marginal with this, my favorite boring bar. But I'm just going to have a look at it because I think I can make this work by doing it as a facing path, taking lots of small depth of cut passes. Nope. No, there's not enough clearance under here. Let's hope we have something in the random lathe tool drawer. Oh, right. This is a carbide boring bar, left hand turning, but otherwise that'll be perfect. This is set at the right height, so what do we need? We need 55 millimeters. Okay, let's add a new tool. Let's give it the number, twist, drill, all that center stuff I'm putting in the 20s. So let's call this one 26. Click OK, following an error. Obviously it doesn't like having the tool created and then used immediately, but it's 26, it's in there. I'll just give it it has no tool offsets at this stage, but I'll just set it into G46 offset mode. So the next thing, we'll do a test cut and measure it and set that as well. Okay, didn't set this up so well because I've now got a bit of a nasty interrupted cut to do there. No, it's cutting beautifully. Cool. Now I'm going to use this to cut its own taper because this lathe macro can accept a taper angle. Got a wee ways to go yet, so I'll keep beating up this insert, and then when I get close to the end I'll switch it out for a fresh one. Right, there's a fresh insert, and I'm going to need a better surface finish than that, so I've cut down the feed rate and also the depth of cut, and I'll add a bit of coolant this time, something to lube it. Ain't that just typical? Kind of a bird's nest on the last pass to rough up the surface finish a bit more. Right, so the last lathe operations, I just need to clean up the shoulder, put a slight undercut down here with a radius at the end of the taper, and then put a chamfer on here. Well, that sounded awful. Oh, didn't tighten the lathe tool. Man, that was a dumb move. Last operation is going to be the M16 thread down in here. Well, that was really quite a lot of work for just two simple components. Pretty happy with how they came out. Not perfect, I made a few mistakes, but I think they're functional. Right, give this a blue up and just see what it looks like in the Maho's taper, Maho spindle. Guess I really need to take those keys out so I can turn it. It's touching quite well at the bottom and at the top. Not sure how much better I could expect than that. I'm not sure how well you can see this, but that's actually a feature of the spindle. See how it's got a band to carry the load at the front, then it's relieved, and then there's a second band further back. So you're never going to get full contact with a Maho spindle. It's only ever going to carry load on two strips. So I'm going to call that a pretty successful taper. Awesome. Let's assemble it. Well, that was a surprisingly large amount of money for a pretty small, normally easy to buy part. So first the screws all the way until it bottoms. Just need to deburr those last bits that I cut. Next the arbor screws on until it just about hits the drive keys. And here's kind of the unintuitive bit with these differential screws. Now I back off the screw, so it's winding out of the bottom thread by 1.5 millimeters per turn, but winding into the top at 2.5 millimeters per turn, and therefore it pulls the thing up tight.
So these have been known since 1667. Who'd have thunk?
Then it's just a pull stud and we're ready to test the thing. Right, very unscientific test because I'm not putting any form of calibrated load on it rather than just leaning on it. But what sort of deflection do you get with a tool of similar length when I sort of lean on it? Get a couple of hundredths of deflection. Leaning on it, I can also get a couple of hundredths of deviation there as well. But it doesn't seem hugely different. Look, unfortunately I'm so far out of time now that I'm not going to have a chance to actually test out the boring head. You'll have to wait for a future video if you want to see this in action. It's a very cool head. It can do both normal, fine adjustable boring, but also can actually flatten a surface or also cut cones. So there we have it. I'm pretty happy with how that came out. Thanks a lot for watching.